Have you ever wondered why some woods are heavy and strong, while others are light and easy to work with? Or why certain timbers resist fire, insects, or moisture better than others? The secret lies deep inside, in their cell structure. Hardwoods and softwoods may both come from trees, but their microscopic makeup completely changes how they behave. Those tiny cells decide everything, from a wood's strength and weight to how well it takes polish or paint, and even how easily it burns or absorbs water. Hardwoods usually have denser, more complex cells, which make them heavier and stronger, perfect for furniture, floors, and structures that need to last. Softwoods, on the other hand, have simpler cells with more air spaces, making them lighter and easier to cut, ideal for framing and roofing. But the story doesn't stop there. Before any timber can be used in building, it needs to be seasoned. That means drying it until its moisture level matches the environment it'll live in. Timber used outside usually holds about 16 to 18% moisture, while indoor wood needs to be dried down to about 8 to 14%. If the moisture stays above 20%, fungi can take over, and that's where decay begins. Seasoning isn't just about preventing rot, it also stops wood from twisting or shrinking after it's installed. The formula for moisture content is simple: wet weight minus dry weight, divided by dry weight times 100%. Now, in the past, builders often used unseasoned or green timber, especially for traditional timber frames.
It's softer, easier to cut, and actually designed to move over time.
That's why old wooden buildings sometimes look slightly bent or uneven, yet still stand strong after centuries. Their secret? Flexible joints pegged together, letting the wood breathe and shift naturally with changes in temperature and humidity. Even smaller wooden parts, like wattle frames in old walls or thatch fixings, were used green for flexibility. They came from coppiced or pollarded trees, where new shoots grow from old stumps, giving a constant renewable supply. When it comes to shaping timber, builders use different cutting methods depending on what they need. Timber can be cut tangentially, along the curve of the grain, or radially, straight across from the center. Tangential cuts move almost twice as much when they shrink, which can cause warping or twisting, something you might notice in roof shingles or old floorboards. Today, we also have modern timber products like laminated beams, plywood, chipboard, fiberboard, and engineered timber. These materials make use of every part of the tree, even small chips and fibers, reducing waste and boosting strength. Some architects are even using thin forest thinnings to create bent lattice structures that support green roofs, blending sustainability and creativity. So, next time you walk into a timber-framed home or lean against a wooden handrail, remember that wood is alive with science and history. Every grain line tells a story of strength, flexibility, and adaptation. Here's a question to leave you thinking. If every piece of timber moves, breathes, and changes with time, what does that tell us about how buildings should be designed? Should we fight against movement or learn to build with it? Subscribe for more.